Making this video to show you a mistake that almost everybody made on this, and it's because you assumed that all the parts that I gave you on that handout would work and were correct. Most of them do. But when you do an interference check, look at the interference. I want you to analyze it. Now this is one project, and if I do my interference check, I just go over here and do the whole thing. I get 3 interferences that I expect, I think. The problem is that one is not one I expect. That's where there is a overlap on the Woodruff key. I do expect one between the shaft and the nut that I don't get, because normally you would make this the major diameter and the hole in the fastener the minor diameter. In fact, let me just check one thing here. I'm going to open that up. And there's the problem. That was made 16. So that really should be 14. At least the way I do it. Now, it doesn't have to be. I wouldn't call it wrong. I'm not calling this one wrong. But if you make that size, which is the minor diameter, and you go here, it reinforces that you understand what a minor diameter is. Then I get back in, and I say I want to rebuild this. Now when I do an interference detection, I'm going to get 4. And I do expect to get one of them, another one of them, another one here, but I don't expect that one. Now that one's a little bit subtle. If that was the only problem with this, I would have just said okay, but you can see that it's got an interference between the Woodruff key that's sticking up into the washer. That's because it goes back too far. So something went wrong there when you see an interference and you have to fix it. This is the let me see. This is the one right here that most people got, and I know why you did. Most people got it because the parts themselves can't be used the way they're designed. I do this on purpose because I want you to start paying attention to the use of the interference detection for determining whether a design is going to work. So far we've been in school. I tell you exactly what to do, you make it, that's it. You didn't have to make any decisions about it, you just put it all together, it all works. From now on, you have to not only find interferences, but then fix it. So if I do the interference detection again, and I get this and look at it, I expect this one, because I made the fastener, or the person who did this made the fastener the major diameter, and made the hole that's in here the minor diameter, but what's up with that shoulder right here? That shoulder could not possibly be embedded in this. All you did here, or somebody did, was made a coincident relationship here, and it turns out that shoulder is too long. Not only is it too long, but if you moved it out and made it so it touches this, now the screw would not tighten down because the head would never hit that. The shoulder would hit this instead. The solution to that is to redesign this. And again, almost everybody had this problem, and I understand why, and I wasn't going to, I wouldn't have said do it again if that was your only problem. Doesn't look like that. There might be 2 threads on here. So the problem is right here. That is much too long. Now maybe if you made it, say 18. Now we rebuild that. Now that shoulder gets pulled back a little bit. Now putting that so it goes right up against the frame would work because this would not hit anything. So if we go back now and take a look at the assembly, and then I look for an interference detection and calculate it, I'm still going to get an interference here because I still have a part that was made with a major diameter. But you'll notice it doesn't show the overlap between the shoulder of this and this. In fact, there's a little bit of a gap there, which is exactly what you need in order for this to tighten down. That tightens against here, pushes it against here, that's what keeps it from turning. So there needs to be a gap between that shoulder. And if we just cut it in half, looks like that. So now you'll notice the part itself, there's a shaft going through, the interference we expected, a little bit of a space here, so that hits this. You turn it, it tightens the frame against the base. And then this interference is the one you expect because that's the major diameter. The hole through here is a minor diameter.